Hello everyone and welcome back to PostNetwork Academy's Data Science and AI lecture series. I am Bindeshwar and today we are going to dive into an exciting topic that is the key to understand data distributions, which is skewness. And for more resources you can visit website www.postnetwork.co, YouTube channel, PostNetwork Academy's Facebook page and LinkedIn page. So let us understand what is skewness. What happens when mean and variance are the same in two different data sets? The distributions of the data could be still very different in terms of their shape, with respect to their symmetry and the spread of data points around the mean. This is where skewness becomes crucial for further understanding the underlying data set distributions. That means some datasets with the same mean and variance can look so different. The secret lies in their shape and symmetry, which brings us to the concept of skewness. And skewness helps us understand the symmetry or lack of symmetry in a dataset's distribution. Let us see the two datasets. These two datasets have the same mean and standard deviation, but if you see their shapes, these shapes are very different. So you can say that these two data distributions have the same mean and variance, but shape is different. The first one is zero skew distribution or without any skewness. Second has some asymmetry or skewness. Now let us see definition of skewness. So skewness refers to asymmetry or lack of symmetry in the shape of a frequency distribution. That is by from Morris Hamburg. Second definition, when mean and median fall at different points in the distribution. That is by Garrett. Third, when series is not symmetrical, it is asymmetrical. Very simple definition. In simpler terms, we can say that skewness gives us a peek into the shape of our data. Now, there are two kinds of skewness. The first one is the positive or right skew data. So in positively skewed distribution, the right tail is longer than the left tail. The majority of data values are concentrated on the left side. You can see in the figure. While a few larger values stretch the distribution to the right. Now see the examples. Most customers at a retail store make small purchases, but a few make very large purchases. You can see that in the right side. Few customers makes large purchases and that stretch the distribution to the right. So this distribution is skewed distribution. Let us see negative or left skew data. So in a negatively skewed distribution, the left tail is longer or fatter than the right tail, and the majority of data are concentrated on the right side of the distribution, while a few smaller values stretch the distribution to the left. Example will clear all the things. So in a class, most students score very well when exam is easy, but there are still some students who do not perform well or perform poor, the distribution of scores will likely be negatively skewed because the low scores drag the average down. So, a negatively skewed distribution has longer left tail, where the most values are on the right. Now, so why does skewness matter? Understanding skewness helps data scientists and analysts identify biases and make informed decisions about the underlying data. That wraps today's session on skewness. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more videos from PostNetwork Academy Data Science and AI lecture series. So again, thanks for watching the video.